Hey guys, today we're going to learn about how light passes from one medium to another. Obviously this is called refraction. We've already learned this, and as you recall, the speed of a wave will change as it enters a new medium. So for example, if we have light moving from air to water, it will change its speed and move more slowly through the water and move faster through the air. And as you hopefully remember, slower means a smaller angle, which means if we have light, remember this word, incident, on a boundary, instead of calling it theta sub I, I'm just going to call it theta sub 1 for medium 1. And this will be theta 2. Will theta 2 be smaller or larger with respect to the normal line? Of course, since it's slower, theta 2 is smaller and it bends inward. If the incident medium is slower, such as a solid like glass, and the refracting medium is faster like water, or we could have water to air, but I'll do glass to water. Then if we have light incident, faster means a larger angle. So if you recall, faster, of course, means the wavelengths must be spread out, which means the wavefront has to bend, and for this to keep consistent geometry, the angle with respect to, don't forget, the normal line must increase. So if we throw in one more thing here, the index of refraction of air is about 1. Maybe I'll just say that it is 1 for easy assessment. And water is a little bigger because the velocity is a little slower. So notice how slower means a smaller angle, which means a larger index of refraction. And faster, of course, with respect to glass, which has an index of refraction of 1.5, because it is even slower than water. The smaller index of refraction here will have a larger angle because it is a faster substance with respect to the incident medium. And of course, the actual math is Snell's law. If you remember Snell's law, notice how the index of refraction is larger for a smaller angle. So that is a inverse proportionality as opposed to a direct proportionality. It's inverse, right? One goes up, the other goes down, right? So they satisfy an inverse type mathematical relationship. However, of course, it's not the actual angle that is inversely proportional to n. As we discovered in class, it is the sine of the angle. So n1 sine theta 1 equals n2 sine theta 2. Just to show you guys that this is the same thing as in class, we can replace n1 with the definition of the index of refraction, which of course is that speed of light divided by the velocity through the medium. And we can replace n2 with its corresponding definition. And of course cross out those speeds of light, and we end up getting the exact same thing that we got in class, that sine of theta 1 is directly proportional to the speed. That's a direct relationship. So if you have a faster speed, right here, faster means a larger theta, which of course is inversely proportional to the index of refraction n. Whereas slower is a smaller angle, that's a direct proportionality, inversely proportional to the index of refraction. Definitely make sure you can draw the pictures. You understand the concept. That's the most important part. What I'm going over right now, this box is everything. If you understand this, you are great. By the way, this logic goes both ways, meaning one implies the other. So if you know that it's a smaller angle, you know it's slower, you know it's a larger index of refraction. It's all connected. Nice and beautiful. Yay, physics. All right, guys, I'll see you in class.